this afternoon. I will introduce the person that will be in charge of open science for the next whatever years. So from the 1st of we have February, March. Vittorio Iacovella will be the person that will carry on the project on open science. So whatever will be in relation to open science, Vittorio will be the reference of this project. So now I've introduced Vittorio. Vittorio will introduce Folco in his... thank you, Vittorio.
Yeah, let's save the claps for Folco. So today's speaker is Folco Panizza. He got his bachelor degree in psychology back in 2014 at the University of Firenze. He then moved to Berlin and he got his master degree in cognitive-based science at the Humboldt University back in 2016, I guess. And since then, he's a PhD student here at CIMeC. He studies cognitive and brain science. He works with Giorgio Coricelli, and he is currently in his third year. His main focus is on neuroeconomics, but today he will illustrate something related to pre-registrations and registered reports, preprints and so on. This will be a hands-on talk, as far as understood. And within the Open Science Seminar framework, this is kind of related to preparation, writing, and publication. So thanks, Folco. Floor is yours.
So yeah, thank you for having me here. Actually, as Professor Minucci just said, that it's like the third time I'm giving a talk on this topic. I try to make it a bit different than previous times, just to update it with your feedbacks, questions, and specifically to actually make it more practical. So yeah, as Vittorio already mentioned, this is a hands-on talk. So I'm gonna introduce these protocols, like I'm gonna explain what the pre-registration is. I'm gonna explain what a register report is, their differences. And after that, I would like to show you how to file one of them. And just to give you an idea of how easy and relatively quick to do it. Of course, this is the practical part, and there's also the thinking part, which could take a lot of time. But yeah, without much further ado, let's start. So, in the beginning, there was preprints. So preprints are a way to disseminate results, analysis, knowledge in a field, which is somehow not official because it's not peer-reviewed most of the time. You share work which you have done, and you get feedback from it. This is a practice that is still fairly uncommon in biological sciences related to the brain, and so neuroscience as well. That's kind of still starting to have in this practice. But it's a fairly common, and actually I would say majority of papers in other disciplines such as physics or economics uses this device in order to share work before it's going through the publication process. So what have preprints as an advantage in terms of as a method of sharing knowledge? It gives you a lot of advantages. In fact, you can receive early feedback from some work you've been conducting, because before even starting a submission, you can understand if your protocol has some problems, if you have failed to, you miss some potential confounds, or there's some additional analysis you could run. And getting advice from your peers is always a very I mean, not always nice, but can be very constructive experience. Secondly, it can give you credit for your work, because people can be concerned about the authorship of your idea. So writing this idea down, making it available in public, somehow gives you some protection of the ownership of the idea. And third, last but not least, of course, we have visibility, because having early access to some work also makes it earlier access gives more diffusion to the ideas. So you can actually advertise it early on in the process. There are several repositories that on the World Wide Web that actually work as repositories for preprints. We have some examples in Archive, or the closer we have here, like for neuroscience and psychology, I would say it's bioRxiv, which is a sort of spin-off. Actually, it's run by different institutions. But what has this to do with pre-registration registerable? So let me get to this point. Like a sort of byproduct of preprints is that when you publish some work online on such repositories, these works are timestamped, which means that if you want to update your work because you've run additional analysis, you've changed some parts of the design of the protocol, you need to make a new version of the same project. And this gives you a temporal evolution of your idea and of your manuscript. So why does that matter? Okay, let's take an example. Let's say you have an idea in mind, and you try to develop a project based on this idea, and you think of an hypothesis, you organize the experiment in order to test it, and then you run the experiment, and it turns out that your hypothesis is not so good. But then, well, maybe I wasn't right in the first place, but there's this other hypothesis which looks so perfectly fitting to the results. And maybe it was this all along. So this, I think, it's a very common process. It happens all the time in all sorts of fields, but I would say especially when you're testing humans, things can get really wrong in the original hypothesis. But we have to make a clear distinction between these two hypotheses. One has been made before looking at data, and the other after. One can be called prediction, and the other cannot. I use this term, which I don't like much, but it's kind of common in the field of meta-science, that discipline that discusses the issues in science writing and analysis. So this term post-diction just basically states that hypotheses after the data are known are like informed by the data, and therefore they have some unwanted features. Let me explain this a bit better. Post-dictions, as this word can sound, are related to the concept of degrees of freedom of a researcher. The idea that once you have knowledge of your results, you can adjust the way you interpret it, the way you look at it. And this gives you a lot of possible ways in which you can manage your data set. And this is statistically, it's a huge problem, because you can look at the same data set, which is somehow objective, but in a lot of different ways, which can lead to very different conclusions. And this causes problems like low reproducibility, false positives, we can get some meaningful, significant results, which is actually not true in reality, or even drawer effects, because we tend to avoid one methods, one process of analysis in favor of another, and someone else tries to run the same experiment using the analysis that doesn't work, and it just wasted a lot of time because nobody published this work. So all these issues are a common problem, especially for psychology and neuroscience. In neuroscience in particular, I mean, I'm focusing here on fMRI literature, mostly because I have fairly little knowledge in other methods, but I guess there are similar papers that discuss this. But there's plenty of issues, especially regarding functional neuroimaging, with like bold fMRI methods, for instance. For instance, the problem that we have too little subjects to test some of our hypotheses. And as I mentioned, the fact that we have a lot of ways to interpret and to analyze the data. So these two papers, for instance, highlighted the problem that looking at a huge data set of fMRI experiments, the authors could not find two papers with the same analysis pipeline from pre-processing to all the analysis. So there's a lot of freedom in the way you can actually process data. So this has brought recently to discuss and propose new ways of controlling for all these issues. One way of dealing with this is actually pre-registration. So, I mean, it's a partial solution to a bigger problem, of course. So, a pre-registration, what is a pre-registration? It's basically a preprint. In many ways, it's basically a preprint. It gives you all the benefits of a preprint, so you can disseminate the work early on, you can get feedback from your peers, you can get credit of your work, but it also forces you quite explicitly to distinguish between your predictions and whatever comes afterwards. Because you basically have a first timestamped version of your manuscript that you can do with continue with your analysis and all the work that comes afterwards, but you still have to stick with the original idea you had. You cannot hide it in a way. So there are multiple places where you can, where can you actually do a pre-registration? There are multiple places where you can do that. The most used platform for doing this is the Open Science Framework, which is a website run by the Centro for Open Science. The Penn University has predicted, and the NIH clinical trials, which are websites where you can actually create one of these pre-registrations and file it on the details. The fact that pre-registrations are basically preprints was actually the way I convinced my supervisors to try this experience myself, because it sort of worked as a Trojan horse, because they were initially very skeptical to the idea, but then I made them realize that both economists as education, and then they realized, wait, how, if you don't have preprints in your field, how do you share your findings before publishing? And actually registration do actually this. It's actually a possibility to have accessible information early on. So I got them convinced just by this argument. And maybe I think it's a valid argument in general. So what brings us? What are the advantages really of pre-registering? Well, as I already mentioned, you are forced to deal with your original hypothesis, and you cannot ignore them or just put them in the drawer, right? So this somehow makes your analysis more reliable and more reproducible, and it also forces you to think, because thinking ahead of all your analysis before you run the experiment, it's a very good training, because you have to think, what is the dependent variable, how do I operationalize it, and what is the independent variables, and so on. And then again, you get all the benefits, as I mentioned, of preprints. There are also disadvantages to this procedure, of course. First of all, most of these websites provide a very limited space where to describe your analysis and project. So I found myself having this problem and not knowing where to put some important information of my protocol. And I got the answer, well, just put it in the other form. You know, there's the other section of the protocol, whatever doesn't fit in the other categories goes there. But I mean, so you can be somehow limited in this. Yes?
Why there is a fixed format and not just a flexible format in the end? What is the...
Okay, so a very good question. I think most of these websites use the fixed format for convenience because it makes works easily comparable and easily analyzable, let's say. You get a very small feedback when you submit these pre-registrations by people who are not in your field, and they get an idea, they get basically the gist of what your work is, and they try to find out if there are some logical flaws or issues. So having a structured protocol actually makes their life easier. I think that's mostly the point of it. Then again, I'm not managing these platforms myself, so maybe there are also other advantages to this.
But again, this feedback, if it is from people that is from a different field, okay, it can be on the logical structure of the work, but still, you mean it's feedback, so it's useful in principle. Was it in that case?
Yes, it was, because actually I missed, for filing my first pre-registration, I missed a couple of, I filled a couple of sections, but not entirely, in the sense that I forgot to mention whether my design included a between or within subjects. These are kind of trivial details, but it can happen that you fail to clarify whether your analyses have a clear prediction or not. And you, as a sole observer of your work, sometimes can miss that, because when you write some work, it's easy to have a blind spot of what you write. So I think it generally gets you also clearer ideas when you get feedback from that. Maybe another advantage of having a standardized form is that the structure being similar between other, it's kind of easy to not to miss information, in the sense that you are forced to fit all information, like variables, sample size, details, technical details, that in a free format will be easy to lose, because you may forget about them. These are some ideas I'm just getting now. So, keeping on with the disadvantages about this is that you're not sure you're going to get feedback, because it's like a preprint. You expect you can share it with co-workers, colleagues, on Twitter, wherever, but you're not sure you're going to get a thorough analysis of what you're doing. And it's easy to cheat as well, in a sense that you can create this protocol, then run your experiment, and just say, to the hell with it. I'm gonna go my own way and forget about my project. Like it's fairly easy to do that. So it's not binding, of course, which is, I think it's a benefit, but at the same time, it's like you have to be motivated to keep your to stick with the project.
But if it can be kept private, then it's not like a preprint. Preprint is public. That's the whole point of the preprint.
Another good point. The thing is, you can ask on these two platforms. You can ask to keep your protocol private for a limited amount of time, and this is just for privacy reasons. In general, all of them in the end will publish necessarily your work as like a normal preprint. It just gives you some time to adjust things, let's say, before you publish it. But this also can be used as sort of wiggle room for deciding, like change of minds are kind of easy. Like you given like three months, if I'm not mistaken, on OSF, like 3 months can change a lot of things. So you can choose to make it public right away, actually, and this is the default option. But then someone can actually use this device and change their mind later. Okay, so there's various limitations to this process, and some people have thought maybe we can make this a bit stricter, and with of course some advantages and disadvantages. So how to make it stricter? They thought about making a thing called Registerable. So what you do when you want to file a register report, and this explains also what a register report is just that you take a pre-registration and you basically put it through a process of peer review, and that leads into eventually to publication. So you bring your idea to some journal, which if you consider the idea valid, it sends it to reviewers. So there's reviewers who control that your experiment is sound. There's all the controls are in place. So you get a technical feedback about your work, and if it gets accepted, of course there can be also rounds of reviews about your work. But if it gets accepted, eventually you get in principle acceptance, which is to say that the journal likes your idea and will publish whatever comes out of it if you stick with the project you submitted. So you are sure, no matter what the results are, no matter how nice or fancy they are, that you're going to get a publication, which is, I think, a nice plus of this. Of course, then you run the experiment, you go through another round just to be sure that you committed to all the steps which you pre-committed to in the beginning, and if everything is in place, you get published. So this sounds nice. It basically adds something to pre-registrations. And we can basically say that registration plus peer review before of study and this thing called in principle acceptance, they make a register report. So you can just say it's an upgrade of it. Yes?
How much does it cost, the peer review? I mean, is it for free? I don't
No, it's exactly the same procedure of a normal peer review. So the people are asked on a voluntary basis to give their opinion on the manuscript.
Yeah, but I don't know, maybe, but when you submit an article in a normal process,
Yes.
it costs a lot just to submit, and then you go through the registers, and every time you resubmit the article, you have to give some money. Here is, I mean, you get peer-reviewed for free.
No, the cost is only at the end, when you get, there's a publishing cost, but this comes only at the end, like in a normal publication process. There's, most of these journals are actually from not open access. Surprisingly, most journals that adopt this register report are not open access journals. I mean, they offer maybe open access options, but like I showed you, like Nature and Human Behavior, Cortex, well, it's not Neuroimage. Neuroimage is Elsevier, and Nature Springer, of course. So the costs are a bit less than like open access journals, but it's the same. It's the same fees. It's the same fees. It's actually it's not even that much more work compared to a normal submission process, because the second round review will be theoretically fairly short, because you just need to check all things have been followed thoroughly. So yeah, okay. Let's get quickly to the end of this. Okay, here's a mistake. Well, of course, should we go for a register report instead of a registration? So yeah, here's one. Just what are the advantages? Well, I just said you get a paper accepted even before you run the experiment. That sounds good. You're sure you're gonna get feedback from peers in your field, which is also good because you can actually adjust your experiment. Maybe you forgot something, or you may add something methodologically, theoretically. And I think the most important point is that you don't have to sell what you get, because it's not about making it significant, fancy, or whatsoever. Of course, again, here there are additional disadvantages, because it takes time to run this process. You have to wait for peer review before you can start analyzing your data. My experience with register report were kind of dire, I would say. Like I got a quick reply, let's say a relatively quick reply from my first round of review, and I got like 2 months and something, which wasn't that long. But then after my second round, took very long. Actually, I had to stop at this point for my, just because I had to run the experiment before summer. Otherwise, I would have to wait another 6 months, because during summer there's no participants for the specific thing I wanted to test. So I had to, after waiting for the second round of review, I contacted the journal and told them that I had to start very soon gathering the data, and they replied after some time, asking me what were the status of my data gathering, if there have been any changes. I sent them, at that point, after they replied, I already gathered like something like 20 participants or something. So I had to tell them, look, I had to start this, and like I told you a month ago. And at that point, one reviewer still accepted the project as it was, even with these 20 participants on. The other said, look, you have data now here, so it's no more a register report. So yeah, you get fairly complex situation. Most of the time, and I've been told this is not a common issue. It can happen. And not, I haven't applied to any of these journals, by the way. It was another journal, which is more offers like more a generic audience. So I got a lot of different topics. So yeah, another problem is that each of these journals has different rules. So it's very, like whenever you go through one of them, you don't learn much from the others, because the rules are very different from journal to journal. They have different requirements. Speaking of which, they're most of the time very strict, because in order to have to trust your work, you have to be able to put out some very high quality work. So you need a lot of subjects, for instance. You need to be sure to prove you're able to hold all sorts of strict methodological requirements. Of course, okay, let's get to the last point, and we get to the very quick hands-on thing. I've been a bit too long in discussing this point. Of course, we have a lot of trouble in neuroscience, especially neuroimaging, because it's hard to get to the very high standards that are required for this kind of publications. So there's been some ideas about how to deal with this, and then a recent paper actually put up some guidelines on how to put up a register report for a neuroimaging experiment. So let's suppose we want to register a report in neuroimage, which we're going to look at very soon. We need to know that we have to deal with these problems. First, we need to justify the sample we're going to have. So if we need, okay, we plan to achieve at least 30 subjects for the experiment, and we have to explain why 30 is a good number in terms of, not based on previous experience, previous experiment, but based on data and facts. We have to specify the tools and software, and it's actually surprisingly common to see on a paper that the same analysis has been run first on one software, then the second part on another software, for no reason, for no clear reason, which sounds a bit suspicious. So most journals that offer neuroimaging and neuroscience register reports actually ask you to specify the tools and software you're going to use. Of course, you cannot be sure 100% what will be your pipeline in the processing of your data, but you can build up what is called a decision tree. So you can somehow foresee what the data will look like and what will be your reaction in that case. So you're gonna have, if we're gonna have this specific type of activation, then I will proceed with this kind of process, otherwise I will go with this other procedure, and so on. Speaking of which, we also talk about localizers and regions of interest. This is specifically for fMRI, but I guess in other techniques we can talk about frequency bandwidths. So you have to be clear what is the specific information in the brain that you're looking at. Otherwise, it's fairly easy to cheat. And of course, what you expect from the results. Okay, sorry for taking this too long. Maybe let's try very quickly to see how a pre-registration protocol looks like. Okay. Do I have? Basically, it's this and another couple of slides. I don't know how much time we have.
Problem.
Yes.
In this case, it's not a publisher, so...
It's not this? Okay.
Oh, yes.
Good point. No, right. Let me just... this is not a publisher. Center for Open Science, it's a non-profit organization. It manages, it stores these protocols, but this is not a register report. This is a repository for pre-registrations. So you have just a non-peer-reviewed version of your work, and we can actually make it, wait, let's make it brighter. And so this is just the part without peer review, without journals. All journals which you will try, if you try to file a register report, will ask you eventually to put the manuscript of your work here anyways. So this is kind of a go-to place if you have any questions, issues, and eventually you stumble upon it. So I'll just show you very quickly how to make up pre-registration, which basically is the ground for also for register reports. So first thing, of course, you go to this website, or the link, I can send you the link if you're interested. Or just search for Open Science Framework on Google. So in case you don't have an account, you just sign in, or actually you can sign in with the RSID, so it's kind of easy. So then you're redirected to your account. You type in your password. I'm going to steal it. There you go. And you're basically in. As long as it loads. Okay. Let's maybe make this a bit bigger so you can read it. So you're given two options. You can actually submit a register report. So let's say you've been through the whole process. You've been given in principle acceptance. Then you're asked to store your manuscript in a place, and this is a place to start. One of the places, generally. Or we can start with a pre-registration right from scratch. So let's select this one and call it whatever. Okay, and yeah, it's kind of slow here, internet. Is this wait, let me just reload the page. Technical issues. Sì, no, questo è quello che ho creato l'altra volta, vabbè, se non lo vedo. Ok, so supposedly it should work because we should be able to. So we get to this page and we can file a new registration. There we just click the green button and we ask what kind of registration you want to file. And the very first one is a pre-registration protocol you're going to see here. So basically this is the description of what we want. So let's create a draft. And okay.
Sorry, Folco.
Yes.
So the pre-registration is a kind of step 0 of a registered report.
Yes.
And what are preprints? So I'm getting confused.
Yeah.
I mean,
Preprints. It's okay.
Much later.
It's no. Okay. We can maybe we can talk this. But okay. I can just give you again. The preprint is something you store on an accessible open repository, which everyone can consult.
It's like GitHub. I mean, it's like
This is for GitHub for code.
For
Okay,
code,
we
okay.
can say, okay, the repository is for papers for which have not been published, which are accessible by anyone.
So everyone can comment and give you
Yes,
feedback.
like yes, we can get every feedback. That's a preprint. A pre-registration is basically a preprint on which you have the added requirement that you have to start without having any data, so you start without any experiment done, and you have to be very clear and precise on your predictions. So you have to separate what your predictions before the data are from all the ideas you get after you have it.
So eventually it becomes a registered report?
If you want it to, but you don't have to. It can be. It doesn't have necessary. You can just have a pre-registration and stick with it. If you want to be like if you want to have other features, which also brings other disadvantages, of course. Registered report gives you the advantage of having, as I said, an accepted paper before you have the results. You have a peer review analysis, but of course it makes you. It takes a lot of time. So it's not an obvious advantage to use register report. Depends on the situation. So pre-registration is before. Okay, it's an alternative and let's say a simpler alternative to register report. Okay, so the forms are very easy. I'll just go to the variables because section basically every line here is one page on the protocol. And I think this is the most important page because I think it's the core of the registration because you have to be clear and not only it's like in words but also let's say like in practice about how do you measure your hypothesis. So you have to use concrete variables with all the calculations involved. Of course, you don't have to be too technical if you don't want to. It's the important thing is that variables need to be clearly defined in a way that you cannot have room for interpreting it, and it can be easy for an external observer to read this information and to replicate what you're doing. So here we have, for instance, a section about manipulated variables, or the independent variables, which can be the stimulus type, the onset, the duration, all these sorts of information. And then, of course, the measured variables, which are the dependent variables. And then, of course, any sorts of other computations you want to make clear. For instance, in my case, I needed to compute an additional formula which which was based on the dependent and independent variables together, and so there's a section for this. I had to fill this in this section. So basically, any combinations of measures. Of course, this is not a technical protocol. So you're not asked about specific questions. You're gonna consider yourself how much into detail you have. But consider the two things. It is is it the two questions? So is it reproducible, and does this give any room for interpretation, which it should not. Okay, so I mean a formula is the best thing, I guess, in most cases. So this page is, I think, is the most important. Then we have the page related to statistical analysis, which you have to fill in what kind of statistical tests you're going to use, whether they're, for instance, for null hypothesis testing, you're going to be asked like, how many tails does the test have, multiple comparisons, corrections, and type of indices, if there are many, and transformation, if you need to transform data, you need to pre-filter them, again, we need all these sorts of information. That exclusion, this is very important because you need to be clear right from the start what are the factors that could invalidate your data, and you cannot just make them up after you look at the data. This is something you should be clear right from the start, and you should think this very thoroughly. And missing data is in case you're not, which is quite common. You're not able to gather. I mean, some participants' data go missing. There's some problem with artifacts and so on, and you just have to be clear on this, of course. Then there's a section about exploratory analysis. This is important. I didn't mention this yet, but pre-registrations nor register reports, neither of them force you to be predictive of everything. Right? There's a lot of room for you to be open to exploration. It's fine. Basically, the rule of thumb is this: if I cannot make a clear description of how I'm going to test this and what my predictions are, then this goes into the exploratory, which is fine. It generally is better if you have a more strict understanding of your hypothesis and questions. So it's generally better, of course, if you have less exploratory analysis, but it's always possible and it's considered in the protocol itself. Okay. Yes, and other things here include the sampling plan, which basically you can explain if you have some pilot data, for instance, which can happen. This is also fine. You can have some pilot data at the beginning. Explain why you have it, of course. How you're going to gather, well, these are, you basically build up the method sections of your paper already. It's a good exercise in this. And for also another important part is, of course, explain how you're going to determine how big your sample will be, which I think is often overlooked part of the experiment design. So you also have to think about this. You have a question?
Yeah, question, yes. I imagine that if you plan, let's say, just an incremental study or variant with respect to the previous study to be detailed and accurate, and the description would be, let's say, not easier, but let's say straightforward.
Mm-hmm.
Otherwise, what I would expect is that it's very difficult to detect all the important details. So, in this case, it's allowed to run a pilot just to meet all the details you have to take into account and then register the record.
Okay, very good question. Absolutely, the point of having a pilot data and the why and the explanation of this is it's basically most of the time for this reason, because people need to have a sneak peek, a sort of early view of what it may look like, of some phenomenon I have, like I just barely scratched the surface. So these are, of course, actually they're part of the process. So if you start a project from scratch, it is fairly common to have a pilot data to shape your initial prediction, as long as this is not fully developed into like an experiment itself. You can have early piloting can mean like gathering some subjects just to give an idea whether the software works, whether the effects can somehow be detected. The important thing is that you cannot make much inference out of the pilot. There is very little insight into the actual results, but it gives you an idea of an estimate of the magnitude of the effect. If you expect this phenomenon to be quite clear, quite evident, then you can be more confident that the sample size doesn't have to be big, for instance. And then, of course, I mean, these are all informations which you have to. And I've been asked about this. I mean, finding the register report, I've been asked, like, look, in order to estimate your effect size, so how many subjects you will need in order to have a meaningful result, you may look at pilot data, which I didn't have, unfortunately, so I couldn't. I had to just guess. Luckily for me, it was a good guess. Yeah, I mean, it's sometimes you're actually asked about this in journals. But then again, just make it small. And give it a clear explanation. Like, this is a new project, this is a new idea, there is some previous work about it, but gives a very limited understanding. Okay, so sample size, stopping rules, this is just, if depending on how you adopt, this is mostly a problem for null hypothesis testing, meaning that people may think that they're not satisfied with the results because they don't have enough subjects, which is not a scientific reason for continuing gathering data. You need to have a clear reason, and this is a place where you have to define when to stop gathering data or when you need to gather more. Because it's easy to fool yourself in a sense, also on this. Okay, so this is just to give you a very broad overview of the thing. I don't think we have time. Maybe we can do this another time if you're curious. We can look up together for each single section if anyone's interested in this. But this is just to give you an idea of what is asked specifically in a protocol. Okay, so I want to conclude. I think I mean, this has been going very long now, so let me just wrap up. Yeah, okay, I think we can look at this later. Let's just go to the summary, I guess. So, pre-registrations are register reports. So, as I said, the pre-registration, it's basically a document available online at an early stage, so generally before the experiment has been run or before we have looked at the data. It forces you to understand what were your predictions before looking at data and after that. It improves, generally improves the quality of your experiments because it forces you to think about all the tiny details which make up the structure of it. It's of course it's problematic in the sense that you are the ruler of yourself, so you decide whether to follow it or not, and it's very easy to convince you that it's not important to follow it. And you're not going to be sure you get any feedback about this before you actually submit it to a journal. And instead we have register reports, which are some kind of a grade of pre-registrations in the sense that your idea goes through peer review. So there's other scholars who look at your work or your idea. You can get an early on acceptance of your work even without the results. You are less concerned about the results looking fancy, because if you got accepted, there's no reason for it. I mean, unless you're for an aesthetic one. It's more rigorous because there's no way you have to stick with the rules in order to publish. It's a problem because it generally requires very high quality requirements. So in terms of statistical analysis can be somehow burdensome. It takes time and it varies a lot from journal to journal. So yeah, this was a very rough overview, and then we can discuss any problems or questions you have. So yeah, thank you.
have this pre-registered report, I think, because if you don't find the effect that you expect, you still can publish it, right? If everything goes fine. Is there also some benefits for this pre-registration with respect to the publication process? Do you know something about that? Whether it helps you to, if you don't have that convincing results, or if you have a null effect, you say, okay, I have pre-registration, and then it's easier to publish it?
Okay, good point. In practice, no journal has any commitment to prefer a pre-registered work over a non-pre-registered one. That being said, there's been more and more awareness about these issues in the field, specifically from psychology. It has moved also into neuroscience more recently. So journals are starting to pay attention to this. And in general, I mean, there's no data on this yet, because it's still a nascent thing, and it's hard to have clear controls. But like editors in general, and there's many journals who have this, like many editors tend to have more trust, let's say, into a manuscript which has been pre-registered over one that hasn't been. Also because it actually, if you stick to that, you probably have been very clear and precise in your analysis. And it's actually, this makes a very easy to read manuscript generally, and fairly strong. So yeah, it's fairly arbitrary so far. We don't have clear data on this. I don't have at least. But and then there's some journals who give badges about, like, if paper had pre-registration before, you get a badge for having pre-registered. Like if you have open access data, you get a badge. Yeah, hooray me, that's that kind of thing. That's what we have so far. I think that the most important benefit of pre-registration is for yourself. The most important point is that you understand how much influence you can have on the whole process of interpreting your results. And you have to be aware of that. Yeah, sorry.
Just a summary, just to understand the entire process.
Yes.
So you basically pre-register your study, you have some ideas, then this can become a registered report, then
Yes.
you have your data, they don't match your expectation maybe, but then if it is a very good registered report, it can become a publication anyway. But
Yes.
then you want to go back and modify your assumption, or maybe it does not.
No, okay. That's
And then you have you loop into this one, and but then basically at every iteration you need to have new data. That's the whole point.
yes. So it's still very in development as a process, but the idea is that there is this let's call it a problem that you want to update your hypothesis, you want to update your results, and it's not entirely clear how to do this within this framework. Well, the main idea is, the proposal, which is still in development in some journals, is that you can have a chain of projects which are connected as like follow-up projects. Of course, your data inform your new hypothesis, so you're gonna have a new idea, a new work. There's no problem in that, actually. That's how incremental knowledge works in general, especially in science. So the idea is that as soon as you have a result, you can just create a new project, a new register report, and you have, okay, then we have this information, we have more knowledge into this field, and we can have a follow-up work. This works not, I mean, I don't know yet of journals who offer like follow-up works, but pre-registrations already have formats which basically clearly state that this work is a follow-up of another work, previous work. And it's incremental, of course. You already have some knowledge, you have some ideas, and you can develop it. Plus, let me be clear on this, maybe I'll go to this slide of misconceptions, because I think it's deviations are very common. It happened, for me, it happened, for instance, for my case, on my register report, and micro-registrations, I found out after gathering many subjects that, that the model I was using had, I didn't consider some literature that could upgrade the model. And that was actually improving a lot into the way it could actually have insight into the data. Now, this somehow could invalidate this could somehow invalidate the ideas and hypotheses that I pre-registered. The point is, it depends, of course. But in general, I mean, these things happen all the time. If you are careful about how you manage them, so in this case, the idea is like, try to figure these things out as early as possible. If this has to happen while you're already gathering data, then let it be. But things happen. You update your ideas all the time, even through the experimenting. The clearest solution here is to actually finish the analysis, run the new analysis, like explaining why you want to improve the model and the process and the hypothesis, and then if that makes if the new improved model, for instance, in my case, makes sense, you can just use it for the following results and experiments as the main method for the experiments. So yeah, it happens. It's very common that something goes wrong, and there's even the most the most predictable investigation of something that turns out in a weird way, and that happens. And you just have to be very careful on how to manage it. Yes.
So from a pragmatic point of view, do you have any kind of let's take cortex.
Okay.
The acceptance rate might be 30%. Let's put it like some fake numbers. So if I go through the registered report, does my chance of getting published increase or decrease? So my point is, the registered report have the same type of acceptance rate as normal paper, lower, higher.
Okay.
So my point is, I have to wait to start my project.
What is the advantage?
What is the advantage? And maybe, let's say, from something completely, unexpected that is really interesting to be published anyways. So may I use the data I published for a pre-registered report also in another way? Obviously specifying that this came out through let's say, an exploratory analysis or by a serendipitous process.
Okay.
So
how much freedom do you have?
no, yeah, how much freedom you have once you register the
Okay.
and what is, let's say, if there are any data, an evidence of advantage for a pre-registered report with respect to a real paper.
Okay. Okay, so these are actually three questions.
Yeah.
So the first question is, within the same journal, what are the advantages in terms of the chances of getting the work published? The second question is, what am I going to do with exploratory analysis? Am I allowed to publish them separately in a different journal? Third question was what was the third one?
So basically, if, let's say, I can publish within the same, I'm allowed to do some additional analysis and publish it if I pre-register it. So it's slightly linked to the second one.
Okay.
So what are the let's say, am I bounding myself to publish only the paper, the data analysis I promised, or may I also try some exploratory analysis? It depends on the journal.
Okay. So let's start for the first question. What are the advantages of registering a report in a journal that offers normal submission process? The answer is generally the editor will be a specific person who has a favorable look at register reports. So generally, I think they go through, let's say, easier life as a paper. The paper goes through an easier life in the sense that the editor tries to gives the paper as many chances as it can. So even if there's a very critical reviewer who can actually support for rejection, given that you don't have data yet, there's some argument which you can just basically restructure the experiment and make it somehow publishable. So it's easier to adapt to the request of reviewers, and the editors are generally more favorable in their decisions. Then you picked up Cortex, which the main editor is Chris Chambers, and I think it's the perfect example where the register report, I guess it's way more advantage, since Chris Chambers is one of the main advocates for this type of protocols. And he's basically an editor in almost all journals that offer this option. About having like freedom on how to deal with your exploratory analysis, or how to, whether to use them somewhere else or to interpret them, it depends on the journal. It really depends. As I told you, journals have very different ideas of how to deal with the register reports. And some journals will allow you to do whatever you want with your data, which are not inside the protocol. Most of them, obviously also for their own interest, they force you to sign some agreement for which you have to somehow use this information within the same journal. I mean, the easiest way, I would say, in general, also for the researcher, is to make this just another section of the same paper. Because generally the results, even serendipitous results, are generally connected to the main one. If I were not convinced by the journal itself, and I'm very excited about the results, nothing stops me from just redrawing my submission and submit somewhere else. And you can do it. I mean, it's not nice with regards to the journals, but it's your choice. You can do it. And most of the time, it's up to you to do it. So yeah, I hope I answered your questions. Yeah.
I don't know if I missed the passage, but so this kind of in principle acceptance, does it differ from an actual acceptance of your final product? Because they accept your pre-registration or your registered report, but you're not going to publish the registered report, you're going to publish an actual paper.
Good point.
So yeah, if you go and comment on the second peer review part, because...
Yes. So, very quickly and easily, the first peer review somehow freezes the manuscript. It gives you an okay of the paper without the data, and it's a publishable thing in itself. It's a theoretical paper. It's like, if we run this, it's like, say, thought experiment, let's suppose this happens, then we expect this. And journals value this. And many journals actually make you sign, you have to sign this agreement for which, if you get a principle accepted, the journals can reserve the right to publish the project proposal in itself. It's still a publication in a way. And it also, it's like, I haven't seen yet, I don't know of any paper which has been accepted in principle and not been published, or in any ways. So I don't know of any paper which has been published at this stage. But it's still possible, and journals, most journals at least, want to have this possibility. Then, of course, the second peer review, it's, as I said, it's mostly to check that all things are like all the requirements hold, all the somehow the commitments are there. Then, of course, the results part are a new part of the manuscript because you just wrote it. That part you're gonna go through the revision, but the most critical part generally, as far as my experience and that colleagues I've talked with, it's mostly about question about the analysis, the design, which we already has been already discussed. So results follows somehow from the premises. Well, I mean, not the exact results, but the way they've been produced, it's clear. So there's very little to discuss here in general. I mean, unless there's something goes wrong. I mean, yeah, as I mentioned before, as an example, things can go wrong. As I said, my case was the method, but another example is that you don't get enough participants because something goes wrong. That can happen too. Then you should discuss this here. Like, look, we have this problem. Then, of course, there's the editor and the reviewer have to ponder whether this is an absolute issue with the thing. Some journals are stricter, some are less. So far I cannot tell which is which. But these things are fairly common, so I assume as long as they're fairly good, fairly well justified, it shouldn't be a problem. Okay? Yes?
Just one question. In principle, if I understand well, you run your experiment, this can match your expectations or not.
Yes.
In case they are not, okay, it can be still a registered report that becomes a publication if it increases acceptance, but then you go back, you refine your hypothesis, but then you need new data because this was made on the data that you just collected so far. But then you publish this data set. And I want to use it, for example, I work mainly on metals and imaging data, so for me, working on data acquired by other people is so common.
Yes.
But then I cannot, I don't know, it's okay, it's not you working again on the same data, but it's me, is that different?
It's very different. Actually, there are, this has been thought of, in the sense that preregistration don't have necessarily to be on data which have not been gathered yet. The important point is that you haven't looked at the data yet. So the thing is, there can be a data set 20 years old, but if nobody has seen it, and or you cannot have any information from it yet, then you're eligible for our registration, and as well for registration.
This is totally against, let's say, public data sets, like Human Connected Project.
Yeah,
Everyone
okay.
is using it, we will be used in for 10 years.
That's the point. If the data are already been studied, and then of course, the Human Connected Project has been studied over and over in different ways, this is not eligible for registration. This specific case, which I think it's also very common, I guess, if you look at methodological literature, let me think for a second.
I mean, if you run a new analysis that never been done on that kind of data set and you are never...
Yeah, but you cannot be sure that to have tested in advance your...
Yeah, no, it's fact. So no, I guess that this falls into some of the circumstances in which it's not possible to be 100% sure that your predictions don't come out from previous information about this. And I think the Human Connectome project, it's one of the biggest data sets we have on the brain, and so it's extremely complex, and there's multiple ways to look at it, of course there's a lot of connection between all the information that we look at it. So as I said, these kind of procedures are part of a solution to a bigger problem. And when you do these kind of analyses, mostly building on others people's work on the same data. So I don't think this could really apply well in your situation. But then again, I'm really not the expert of the case. I'm just giving you.
Moreover, OSF is also, let's say, hosting data sets and sharing them as far as
yes, data are publicly accessible. Yes. So yeah, you can. You can run all sorts of analysis on the public repositories. The idea is again, depends on the way you look at the data. If your questions are very different from the original question, so there's no connection nor a clear direction that could come out from the previous experiments, the previous data. In principle, this shouldn't be a problem. So yeah, you have data. Generally speaking, most data come from disciplines in which you have specific experiments, specific technique, and then there's not so many useful ways to look at it. When you're talking about the brain, of course, things get a bit different, because then you can look at and like ask very different questions about the same data. But then the rule of thumb is this: if I cannot get informed about what the outcomes before I look at the data, then I can make in principle a registration.
There's room for one question.
I'm very happy about this, but
I was wondering if why with the pre-registration the experiment is public. What about Registerable? Is public after peer review, the first peer review, or?
depends on, well, there's been a huge debate on this, because journals generally commit to the publication of first stage. These are also called first stage manuscripts. So far, I don't remember the statistic exactly, like 40%, 50% of journals do this. The others are actually in the process of changing their policies to do this, because there's also all sorts of privacy issues, because there is no, it's a sort of an hybrid work here, because we don't have the complete work, and there can be decisions by the author itself to decide to keep this private for some time, as for the pre-registration. The idea is that this should be accessible in any case, I mean, in principle, but as we know, like all things that involve new policies and new ideas take time to change. So yeah, I would say 50% of journals, around 50%, do publish this, do make this available as soon as it's accepted.
Other questions? Okay, so thanks for